All right, let's move into the analyzing graphs section, number 5 and number 6. The graph below shows the speeds of 3 different cars driving on the same highway. First things first, I want to look at my axes. I'm looking at miles driven on my y-axis, and I'm looking at hours driven on my x-axis. That's really important when we think of what the constant of proportionality will mean. I know the constant of proportionality, or k, is always equal to a y divided by an x. And in this case, that would mean miles over hours, or miles per hour. So when I find the constant, I know that means miles per hour. So let's look for some ordered pairs. For car 1, I see a point at 1:30. So car 1, I see the ordered pair 1:30. That means for every 1 hour, my car travels 30 miles. Or 30 miles in 1 hour, which is 30 miles per hour. So my constant for car 1 is 30. Car 2 is a little trickier. Car 2 doesn't quite hit anything at the next value of 1. It almost hits 45, but not quite. So let's continue on the line. I'm tracing that line. I don't see it hit anything until up at 3 hours. And that's at 120 miles. So for car 2, I'm looking at the ordered pair 3, 120. That means for every 3 hours, I go 120 miles. Or 120 miles over 3 hours, which, if I divide, equals 40 miles per hour. So for car 2, my constant of proportionality is 40. Car 3 is easy again because I see right away I have a point at 1 hour. So I can jump right to my unit rate in this case. My ordered pair here is 160. Remember, the ordered pair that represents the unit rate has a 1 for an x. So in this case, I see it was 60 miles per hour. For the meaning of each of these, we just have to write a little bit of a sentence. So for car 1, the meaning of my constant of 30 is that car 1 travels at 30 miles per hour. Car 2 travels at 40 miles per hour, and car 3 travels at 60 miles per hour. You guys can fill those in on your own. Now we want to write an equation. Now for writing an equation, I want to do y equals my constant, or k, times x. Y equals kx. So for car 1, I wind up with y equals 30x. For car 2, y equals 40x. You guys figure out car 3 on your own. Alright, that's it for number 5. I'll pause for a second to let you copy it down, and then we'll move into number 6. During a recent rainstorm, 2 different nearby cities received different amounts of rains. The graph below shows the rate of rainfall in Metropolis. So we're looking at a graph with inches of rainfall on our y-axis and minutes on our x-axis. And we are told that it rained 3 inches more per hour in Gotham City than it did in Metropolis. Now, it's important to pay attention to units here because on my x-axis, I am given minutes. But in this sentence here, they tell me Gotham City was 3 inches more per hour. So I need to find out first what Metropolis's rate in inches per hour is. Now, if I'm looking at the graph here, I see 60 minutes shown on my graph. This is 1 hour. So if I find how much it rained in 60 minutes, I can figure out how much it rained in 1 hour. So in Metropolis, I see that it rained 2 inches in 60 minutes, which is the same as saying 2 inches in 1 hour. So Metropolis rained 2 inches per hour. Now, if I know Metropolis was 2 inches per hour, and Gotham City was 3 inches more per hour, I know that Gotham City would be 2 plus 3, or 5 inches per hour. So I'm going to write down here, Gotham, you guys have this written on your pages, and Metropolis. Now in Metropolis it was 2 inches per hour, and in Gotham it was 5 inches per hour. Now I'm also asked to figure out the inches per minute. Now if I go back to Metropolis, I know it was 2 inches in 1 hour, but I also know that was the same as saying 2 inches in 60 minutes. What I want you guys to do is figure out how to scale this down to 1 minute. And figure out what the numerator would be. Same for Gotham. I know it goes 5 inches in 60 minutes because it was 5 inches per hour. I want to again figure out how to scale that down to 1 minute. How do I scale that down to 1 minute? All right. You guys figure that out. Put it in your packet. And that would be your answer for the inches per minute. Your answer for those will be a fraction. All right? So right now you guys should pause the video and move into the rest of this section. When you finish, you can check out the answers for the rest of the section. All right, here come the answers. For number 7, we see that the speed was 6 miles per hour for Anthony, 5 miles per hour for Storm, and 4 miles per hour for Bree. And then when we find the miles per minute, remember I'm scaling down to 1 minute for those. Anthony was 1/10 a mile per minute, Storm was 1/12 a mile per minute, and Bree was 1/15 a mile per minute. For number 8, we find that the constant, or K, was 2/9. I did that by locating the point 9 minutes and 2 miles. I want you guys to figure out the rest on that. Make sure that gets in your packet. All right, that's all for this section.